Hi, welcome to my channel, JaberTime. I have 5 examples to go over. The first 2 are graphing exponential functions. One is decay and one is growth. The second 2 examples are interest, compound interest quarterly and continuously. And the last example is about average rate of change. Number 1. Graph the following function, f of x equals 1/2 to the power x. So if you keep multiplying by half, the amount or the values will decrease, and you will see how it works. Let's start with 0. For the 0, the easiest one to start with, 1/2 to the power 0 is 1, and anything raised to the power 0 is 1. So what do I have here is 0 as an input will give me 1 as an output. Before we forget and continue, let's mark this right here. Let's go to 1. 1/2 to the power 1 is just half. So the order pair is 1 as an input, half as an output. 1 will take me to half. 2, that's half to the second, which is 1/4. So 2 will take me to 1/4. Half of half, which is 1/4. And 3 will take me to 1/2 to the third, and that's 1/8. 1/8, which is approximate, not approximate exactly, to 0.125. Kind of hard to graph it by hand, but just to know it's lower than this. Let's go to the left, -1. For -1, it's 1/2 to the power -1, and because of the rule that says a to the power minus m is 1/a to the power m. Same thing if you have 1/a to the power minus m, that will be a to the power m. So by applying -1 to both, that will be 1/2, -1 here, -1, and that will change using these rules to 2 regular on top and 1 to the power 1 at the bottom side, which is 2. So -1 takes me to 2. -1 takes me to 2. -2. 1/2 to the power -2. Apply it and flip it. That's going to give me 4. So we have -2 will take me to 4. -2 will take me to 4. -3, same idea, will take me to 8. So -3 output 8, all the way up to 8. If you notice right here, going this way, I was at 8. Every step I'm going down halfway to 4, halfway to 2, halfway to 1, halfway to half, and so on. If you graph it, let's graph it with a pencil this time and show what is going on with the graph. The graph is an exponential decay. It doesn't touch the x-axis, but it's kind of hard to not to touch the x-axis, as you could see. The domain will be all real numbers from -infinity to +infinity. The range will be all the y values greater than 0. So let's write this in different format. -infinity to infinity for all real numbers. Y greater than 0, that means from 0 all the way up to infinity. From 0 all the way up to infinity, not including 0 value for y, which is the x-axis. That's why it's open at 0. The y-intercept, that's this point right there, which is 0, 1. 0, 1. The asymptote, we only have a horizontal asymptote. We don't have a vertical one, which is the x-axis, or y equal 0. Let's write also the x-axis. In behavior, as x approaches infinity, as x goes all the way to the right, my values of f of x approaches 0. F of x approaches 0. As x approaches negative infinity, my values will go all the way up to positive infinity. As x approaches negative infinity all the way to the left, my values will approach infinity. That's an exponential decay. The reason why is b, which is the base. B is half, which is less than 1, and of course greater than 0. In case if you have a number up front here, that will be the y-intercept. The y-intercept is 1 times half to the power x will give me 1 from here. That's the one right there. That should do it for example number 1. Example number 2. Still exponential, except this time we're not dealing with half as a base. The base is 3, and that is greater than 1, so it's going to be exponential growth. And because I have a 2 up front, that's going to be my y-intercept. So let's mark it 0, 2 before I continue. Let's start with 0, positives, then we'll go to negatives. Anything raised to the power 0 is 1. Anything raised to the power 0 is 1. So what do I have here? I do have f of 0 equals 2 times 3 to the power 0, which is 2 times 1, which is 2. As I told you, 0 will give me 2. So the order pair here is 0, 2. For 1, if you plug in 1 here, that's going to be 2 times 3 to the power 1, which is 2 times 3, and that is 6. So 1 will take me to 6. 1 will take me to 6. Right there. 2. Replace x with 2. 3 to the second is 9. 9 times 2 is 18. So we have 2 will give me 18. For 2, I'm going to go all the way up to 18 and mark it. Of course, 3 we can't go and make the scale all the way up, but that just to support that it takes off and it is exponential behavior. For 3, that's going to be 3 to the third, which is 27 times 2, 54. So we have 3 will give me 54. As you can see, 3 will take me all the way more than twice 20 right here, which is hard to reach. Negative 1. As I mentioned in the last example, a to the power minus m will change to 1 over a to the power m. So what we have here is 2 times 3 to the power negative 1, which is 2 times, let's put times right there, 1 over 3 to the power 1, which is 2/3. So about 0.6 repeating, or about 0.7. About 0.7. So negative 1 will give me 0.7. Let me write it right here. Negative 1 point, to be accurate, it's 0.6 repeating. So negative 1, 0.6 will be somewhere right there. Negative 2 will give me 0.2 repeating. Negative 3 will give me 0.074 repeating, which is smaller and even less right there. So the graph is gonna look like this. It's gonna intersect the y-axis at 2, and we found that by plugging in 0 for x, or by looking at this number right here. Of course, that's not always the case if you have a shift to the right or left, of course, or up. It's gonna make a difference. So we don't have any shifts right here. We'll take it from the beginning as initial amount. Okay, to finish the problem, domain, like the previous example, all real numbers. Range, from 0 to infinity, the y values, not including 0. 0 to infinity. Y-intercept, we mentioned it, 0, 2. And we'll write it down here again. the asymptote, which is the x-axis, or y equals 0. In behavior, as x approaches infinity, going to the right, f of x goes up to infinity. F of x approaches infinity. As x approaches negative infinity all the way to the left, my values will get closer and closer and closer to the x-axis. As you could see, they get smaller and smaller. So we're going to say f of x approaches 0. And we could be more clear here that it approaches 0 from the right, from the positive values. Okay, that should do it for problem number 2. So the first one was decay, and this one is growth, because 3 is more than 1. Investment problems. John deposits $1,200 into savings account that pays 3% annual interest compounded quarterly, 4 times a year. Write the function that represents a situation where A is the value of John's investment after T years. So the formula will be the following. That's the amount at the end after T years. The principal, which is the initial amount or the start amount, that's going to be 1,200. 1 plus R, the interest rate, and usually we write the interest rate in decimal form. So 3% has to be converted over how many times you compound the interest, which is 4 times. That says n equals 4 raised to the power n times t, the number of times multiplied by the number of years. Because t is unknown, we're going to just keep it as a formula, but we'll put the other numbers that we know. That will be 1200. 1 plus, one more time, r has to be decimal, so we're going to write 0.03 instead of 3%. The reason why, 3% means 3 out of 100, and if you divide by 100, it gets smaller by 2 digits, or the decimal moves to the left 3 digits. As you can see, this is a place value of 3 hundredths. It's hundreds, this is tenth, this is hundreds. Over 4 to the power 4 multiplied by t. When t is 6, to find the balance after 6 years, of course, since it's money, we're going to round to the nearest cent, 2 digits. The formula becomes 1200 times 1 plus 0.03 over 4 to the power 4 times 6 instead of 4 times t, which is 1200. 1 plus 0.03 divided by 4 is 0.0075. 4 times 6 is 24. We could write this as one number, easier to type when we calculate on a calculator. 1200, 1.0075 to the power 24. Using the calculator, we end up with about $1435.70, about $1,435.70. Of course, if you end up with a number way bigger than this, that means something is wrong, because you can't in 4 years with 3%, let's say double the amount or triple the amount. So that should make sense. Like we are gaining the difference, which is about $235.70. Of course, also if this number is less than this, something is wrong. We are making money with interest, 3%. So just expect that $1,200 will be more than $1,200 by some decent amount. That is compound interest, and it's not continuous. It's the compounded idea. Quarterly means 4, monthly means 12, weekly means 52, and so on. That should do it for the deposit. We have another one that is called continuous growth rate. Alex invested $5,000 in an account that grows continuously at a rate of 2.5%. Now, continuously means base E. And 2.5% should be converted to decimal. I know it looks decimal, but we need to write it decimal. That's a number, a regular number. That means it's 2.5 out of 100. Moving the decimal to the left 2 digits, because I'm dividing by 100, that becomes 0.025. The decimal was here between 2 and 5. Now it's on the left of that place by 2 digits. That's my R, or the interest. The formula for the continuous investments is A equals P as the initial amount or the principal multiplied by the E to the RT. To write the formula or the function represents the situation in general with T years, that's going to be 5,000. That's my investment. 5,000 times E to the power 0.025 multiplied by T. For 5 years, we're going to replace T by 5. So A is going to be 5,000 multiplied by E to the power 0.025 multiplied by 5, which is 5,000 multiplied by E to the power 0.025 times 5 is 0.125. Using a calculator and rounding to 2 digits because we're looking at money right here, that will be about 5,665.74. So 5,000 became $5,665.74. We always need to look at the numbers to see if it does make some sense. It looks like we are making, or Alex is making, what? $665 in 5 years and 74 cents. Okay, that is the continuous growth or exponential function. Now this is an average rate of change. Average rate of change in a simple way could be described as a slope. But as a function, this is a curve. This is not a straight line. For straight line, when you say slope, it's like y2 minus y1 over x2 minus x1. Makes sense. But for a curve that changes values, not steady as a straight line, on average, between two distinct points like 3 and 5, it's like we are finding the average of the secant that crosses the graph at two distinct points. For example, if I travel for a length of 2 hours and I cover 150 miles, total distance over total time will be 150 divided by 2, which is 75. But if you want to add the units to it, it makes more sense. 75 miles per hour. It's like, on average, I was driving 75 miles per hour. Now, that is not true as a curve because I was sometimes over 75 miles per hour, sometimes less, maybe a stop sign, maybe slowing down, exiting from a freeway, and so on. So that's called average rate of change. So overall, from the start till the end, what was my average? It balances to a certain amount. So all what you need to do here is just like plug in the numbers. The average rate of change is y2 minus y1, or f of x2 minus f of x1, since we're using f of x, divided by x2 minus x1, which equals to f of x2, and that's my x2, and that is my x1. F of x2, that is f of 5, minus f of x1, which is f of 3, divided by x2, which is 5, minus x1, which is 3. Doing the math, f of 5 will plug in 5 right here. That will be half e to the power 5 minus 1, minus f of 3 will plug in 3 here, and that will be half times e to the power 3 minus 1 divided by 5 minus 3, which is 2. We could pull the half outside as a common factor. That's one option, 1/2. And we get e to the power 5 minus 1, that's e to the 4, e to the power 3 minus 1, that's e to the second, all divided by 2. Doing the math, that is 1/4 e to the 4th minus e to the second. We're dividing half by 2, that's 1/4. That's one way to say it. Approximate to 11.80. Now we don't have distance and time here to add units to it, but that's overall on average the value of the function is increasing or moving up as rise over run. Every unit to the right, it's rising 11.80, and that should do it. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.